All right, today we're going to go on an incredible expedition, but we're not going across the world, we're going through it. We are taking a journey deep, deep inside our own planet to really understand what's going on right under our feet. So let's get started. So, have you ever really, truly wondered what's down there? I mean, what's in the interior of the Earth? It sounds like a simple question, right? But the answer is, well, it's anything but. Our planet is constantly moving and changing, not just on the surface we see, but deep down in its hidden layers. So what is really going on thousands of kilometers beneath us? Here is our roadmap for this journey. First, we're going to peel back the Earth's layers. Then we'll travel all the way to the core. After that, we'll pop back up to the surface to explore the three big rock families, see how they're made, and finally, wrap our heads around the never-ending rock cycle that shapes our entire world. You know, the best way to think about the Earth's structure is to just picture a giant onion. Seriously, it's made of all these different concentric layers, and each one has its own totally unique properties. We're going to peel them back one by one. So, that first layer, the very ground beneath our feet, that's the crust. It's where all life as we know it happens. But here's the wild part. Relatively speaking, it is incredibly thin. Think of it like the skin on an apple. That's it. That's our home. But not all crust is created equal. The continental crust, the stuff under the land, is way thicker, about 35 kilometers deep. It's mostly made of silica and alumina, which geologists call sile for short. Then you have the oceanic crust, under the oceans, which is much, much thinner, only about 5 kilometers deep, and it's made of silica and magnesium, or seamold. And wow, this chart really puts that into perspective. The crust, our entire world, makes up only 1% of the Earth's total volume, just 1%. The vast, vast majority, a staggering 84%, is the mantle. The core makes up the other 15%. We are truly just living on the very, very thin outer edge of our planet. Okay, now let's leave that tiny crust behind and start our descent, going deeper into the Earth's massive engine room. Right underneath the crust, you hit the mantle. And this isn't just the next layer down. It is the biggest by a long shot. It goes down almost 3,000 kilometers. It's this huge region of super hot, semi-molten rock that's constantly, slowly moving. It's this powerful churning that actually drives the movement of the continents way up above. And at the very, very center of it all, we finally find the core. It's got a radius of about 3,500 kilometers. And it's basically a super dense ball made of nickel and iron. Geologists have a cool nickname for it, NICE. It just combines the chemical symbols, Ni for nickel and Fe for iron. Now, to give you some perspective on this incredible journey, get this. The deepest mine humans have ever managed to dig is only 4 kilometers deep. 4. We've drilled for oil maybe a little further, down to about 6 kilometers. But to get to the center of the Earth, you'd have to travel 6,000 kilometers straight down. It's a journey we just can't make. We've barely scratched the surface. And hey, even if you could get there, you would find conditions that are just beyond imagination. The central core is under this crushing, immense pressure, and it has incredibly high temperatures. This is the powerhouse of our entire planet. Okay, let's zoom back up to the surface and talk about that 1% we call home, the crust. Now, it's made of rocks, of course, but not just one kind. There are 3 major families, or types, of rocks. So first up, we have igneous rocks. Their name is a dead giveaway about their origin. It comes from the Latin word ignis, which means fire. And that's exactly what they are, rocks born from fire. They're formed when hot, molten magma from inside the Earth cools down and becomes solid. Next on the list are sedimentary rocks. And again, the name tells the whole story. It comes from the Latin word sedimentum, which means to settle down, and that's how they're made. These rocks form when tiny particles or sediments from other rocks get broken down, carried around by wind or water, and then they settle in layers that eventually get squashed together and harden over a long, long time. And our third family is metamorphic rocks. This name comes from the Greek word metamorphos, which means change of form, and that is a perfect description. These are rocks that have been totally transformed. They might start out as igneous or sedimentary rocks, but under tons of heat and pressure deep inside the Earth, they change into something completely new. Okay, so we've met the 3 rock families, but how do these processes actually work? Let's take a closer look at how these different kinds of rocks are really formed. Let's go back to those igneous or fire rocks. They can form in two main ways. When molten rock, which we call lava, erupts onto the surface and cools down really fast, it forms what's called extrusive rock. It has very fine grains. Basalt is a great example. But if that same molten rock, called magma, cools down very slowly while it's still deep inside the crust, it forms large-grained intrusive rock. And a perfect example of that is granite. Now, sedimentary rocks, they tell a story of the past. As all those layers of sediment build up, they can trap the remains of plants and animals. And over millions and millions of years, these become fossils, giving us this incredible, sometimes haunting little snapshot of ancient life. And these rocks aren't just sitting around looking pretty, they're a huge part of our history and our daily lives. The famous Red Fort in India, that's built from red sandstone, a sedimentary rock. The absolutely stunning Taj Mahal is made of white marble, which is a metamorphic rock. And that granite we were just talking about, people have been using it for centuries to make things like grinding stones. This brings us to a final, really beautiful concept that just ties everything together. See, the rocks all around us aren't static. They aren't permanent. They're constantly being transformed in a process we call the rock cycle. This slide lays out the whole thing. It can start with molten magma that cools to form an igneous rock. Then that rock gets broken down over time into sediments, which then get pressed together to form sedimentary rock. Put that rock under a bunch of heat and pressure, and it becomes a metamorphic rock. And if that metamorphic rock gets pushed deep enough, it melts back into magma, and the whole cycle begins all over again. It's like the ultimate recycling system. So why does any of this matter? Well, because rocks are made of minerals, and minerals are absolutely essential to our civilization. They give us the fuels that power our world, like coal and petroleum. They provide the metals for industry, iron, gold, you name it. They're even used in medicine and fertilizers. Our entire modern world is literally built from the stuff created by this cycle. And that brings us to our final thought. The rock cycle proves that the Earth is not a finished product. It's a living, breathing, changing planet. So, if rocks are constantly being created, destroyed, and transformed, what do you think the surface of our world will look like a billion years from now? Something to chew on. Thanks for joining this explainer.